with exponents starting this chapter, and in particular today we're dealing with zeros and negative exponents. So, zero exponents. Every non-zero number raised to the zero power is 1. 5 to the 0 is 1. Negative 300 to the 0 power is 1. 49.268 to the 0 power is 1. As long as it's not 0, anything raised to the 0 power is 1, as long as it's not 0. 0 to the 0 power is actually undefined. And then we have negative exponents. Negative exponents. So you switch the location of the base and make the exponent positive. In other words, if you have something to a negative power, you move that base, you move that whole thing either from the numerator to the denominator of a fraction, it becomes a positive power, or if you have it in the bottom of your fraction, you move it to the numerator and make it a positive power. The fraction bar is like this magic wand that changes the sign of your exponents. Okay. Now, we will be evaluating these. So you're going to have to tell me what the numerical values are of these problems. You're going to have to simplify them down. Pause for a second. Okay, most people have the definitions down by this time. So let's do these examples. These are all example problems. We'll do them together. So what you wanted to do is you want to evaluate it. 2 cubed. You understand what the exponent means. 2 to the 3rd power means 2 times itself 3 times. There are certain ones you should know. Your cubes and powers of 2. 2 cubed is 8. 2 times 2 times 2 gives you 8. 2 to the negative 3. Now this is where it gets a little confusing. The negative in the exponent has nothing to do with the sign of the answer. A negative exponent does not give you a negative answer. A negative exponent means that I have 1 over 2 to the 3rd power. The negative exponent means I move it to my denominator and make it a positive exponent, which means that I have 1/8, because 2 cubed is 8. And what is 2 to the 0 power? What is anything to the 0 power? You wrote it down earlier. 1. Remember that. Learn that. Know it. Live it. Okay. 2 squared. 4. 2 to the negative 2 power is 1 over 2 squared, which is 1/4. 73 to the 0 power is 73 to the 0 power is 1. Okay. 2 to the 1st. It's 2. Anything to the 1st power is itself. So that's 2. 2 to the negative 1 means that I have 1 over 2 to the positive 1. So I have 1/2 for that. And then 0 to the 0 power is the only time.
0.
It is not 1. This is actually
What does that say?
undefined. It is undefined. You cannot take 0 to the 0 power. Okay, it's undefined. UNDEF, undefined. Anything else is 1. 0 to the 0 power is undefined. Anything else to the 0 power is 1. Okay, so here's what I want you to do. Problem number 1, these ones here. Do them. Okay. Ladies, gentlemen, focus. So the first one, 9 to the negative 2 power is 1 over 9 squared. which is 1 over 81. 7 to the negative 1 power is 1 over 7 to the first, which is 1/7. X to the negative 3 power is 1 over x cubed, and you can't do anything to that because you don't know what x is, so it's 1 over x cubed. 2 to the negative 4, 1 over 2 to the 4th, which is 1 over 16. 2, 4, 8, 16, yeah, 16. Okay. And then negative 4.567 to the 0 power is 1. Okay. Problem number 2, simplifying exponential expressions. What this is when we have exponents like this, variables, raised to powers, one of the rules we have is you're not allowed to have negative exponents in your final answer. Positive exponents are fine, negative exponents aren't. Thank you. So for the first example, 5a cubed b to the negative 2. The 5 is okay. The a cubed is okay. The b to the negative 2 is not okay. What I need to do is I need to take this and move it to my denominator. So the 5 stays where it stays just fine. A cubed stays just fine. But I take b and move it to my denominator and make the exponent positive. In our final answers, we're not allowed to have negative exponents. So if I have a negative exponent in there, I just move it to the denominator and make it positive. Now, the next one, I already have a negative exponent in the denominator. If I have a negative exponent in the denominator to make it positive, I move it up to the numerator. So 1 over x to the negative 5 is x to the positive 5. That's what it does. Problem number 3, same idea, but you want to evaluate it. So here's what you do. First thing I would do is rewrite this, so I don't have any negative exponents. So I have 3s cubed over t squared. And then I do my substitutions. So I have 3 times s, which is 2 cubed, over t, which is negative 3 squared.
We don't have problems. Yeah.
You don't?
Nope.
Okay, we'll get to that in a second. You can write it down after I do this one. Okay. So from here, remember your rules, your order of operations. Do the exponents before multiplying. You take the 3 and you cube it, and then multiply times 3. I'm sorry, take the 2 and cube it, then multiply times 3. You do not multiply the 3 times the 2 and then do the powers. Exponents first. So this is 3 times 8, and I take negative 3 times itself. That gives me 9. So I end up with 24 over 9, and then we always reduce if we can. They're both divisible by 3. And I get 8/3 for my answer. Big thing on that one is you plug them in. Get rid of the negative exponents first. Plug your numbers in. Remember, you raise numbers to powers before you multiply. So I take 2 and cube it before I multiply it times 3. You don't do 3 times 2 and then cube that. You take 2 and cube it, then multiply it times 3. Right. Now, get these problems written down if you have not already. Okay, let's finish this. So I have 2/3 to the negative 3 power. if I have a fraction raised to a negative power, what that means is I have that fraction inverted raised to a positive power. If I have a fraction with a negative exponent, I flip the fraction and change it to a positive exponent. That's the reciprocal that they're talking about. Okay, that's the reciprocal property. You change it, you make it the reciprocal to a positive exponent. And then I evaluate it. And when you have a fraction like this, that's 3 cubed over 2 cubed. You can think about it like that. Okay. The whole fraction raised to a power means that every part is raised to that power. So I've got 3 cubed. 3 times 3 is 9. 9 times 3 gives me 27. So I get 27. 2 cubed is 8. So I get 27 over 8. So same thing on the next one. My first step, flip it over, change the power, make it positive. So this is n over 3m to the second power. And then my next step is to raise everything in there to the second power individually. So I have n squared over 3 squared over m squared. Everything inside gets squared. Now, there is one other thing we need to do. What do you think I need to do? Try to make it look pretty. What's one last thing to make it look pretty? Well, what can I do? Can I square n? We don't know what n is, right? Can't square m, but can I square 3? Yeah. If you have something like that, get rid of the exponent. So I get n squared over 9m squared. Get rid of the exponent, make it look pretty. Clean it up a little bit. That's the idea behind it. Okay?
Yes.
Questions?
No.
It's not too hard today.